Alright, in this video we'll be talking about supply diffuser auto-sizing families. And I'm going to try to build upon a little bit from the previous video. So I would encourage you guys to look at those user manual sections, and because we have all the parameters laid out with specific instructions and details about what to edit where. And so let's look at the supply diffuser auto-sizing families. So this would apply to the supply diffuser round neck and square neck families. Not all of these types we have performance tables for yet. Those will happen over time, but just be aware of that. So for example, to know if you have auto-sizing or not available, so you could place a family. And in properties here, it's going to say whether auto-sizing is enabled or not. Some of the families, like this louvered face diffuser, which is a very, very complicated family to try to type match. This particular family, auto-sizing is not enabled. And to have this enabled, we have to have a performance table and we have to have design parameters input. So in this case, we don't have a performance table available. So when you guys come across that, just be aware of this checkbox right here. So this given family, you would be on manual sizing. So available sizes for 24-inch by 24-inch modules, all of those. So 24 by 24, and then essentially you would want to give it a size. So let's give it a 6-inch, and then you'll find the family. So right there. So 6, 8, 10 by 10, 12 by 12. This neck size does represent round and square necks. So it's the same parameter for both. So that's your 12 by 12. So that family is not auto-sizing. I just wanted to show you guys that when you come across those families. Let's place one that is. So I'm going to place a very common diffuser, 3-cone diffuser. So we'll place this right on the ceiling. So we have some default design values entered, and we have an airflow that needs to be edited. So let's change this to 700 CFM. So auto-sizing has found a 12-inch neck based upon the design neck velocity. So now this is not design core velocity, it's design neck velocity. So just like the previous video showed, down in data here, these are the values that essentially I'm finding in the performance table. So this performance data URL, we can pull that up and we'll use this to validate a couple more data points. So here are the values being looked up. Max neck velocity comes from design, the design neck velocity. The actual velocity looked up, though, is 1,000 feet per minute, and the size I found was 12-inch. So we're looking for 700 CFM under 1,000 feet per minute neck velocity, and we're in the 24 by 24-inch module. So let's keep going down. And this is the first one that satisfies it, 785. And sure enough, we have a 12-inch neck. So that is another validated data point. So I wanted to expand upon some of the previous videos. So this is the performance table on the website. What it looks like in the CSV file is this. So I've had a lot of help from some people in my office. Zach Klein, he's my man up in Duluth, and Drew Erickson, they've been working on building these performance tables. So if you guys find these guys, you owe them a thanks, because they spent a lot of time getting Titus's website data into a format that we could use in Revit. And actually, it didn't require any data entry. It just required going through a couple different file formats to get there. It's kind of weird how it played out, but we had to go from a PDF from the website to a Word file and then copy that table into Excel and then essentially invert the data in Excel to go down a more vertical fashion, how this is set up. So essentially this family, what we're doing for the auto-sizing piece is, first we're looking for the module size. And so each one of these rows represents one condition for the air terminal from the website. So one row represents, essentially this guy right here. Not the whole thing, but just the 400 feet per minute neck velocity. So one row is this right here. So that's how this essentially got built. So if we go down to 24 by 24, and then, so here's 600 feet per minute. We want to get to 1,000 feet per minute. So 24 by 24, and I should have frozen the panes. Let's go back up here. So view. All right, so 24 by 24, 1,000 feet per minute. Here's some of our options. So the 12-inch neck, as you can see, has a 785 CFM, and that's how we were able to determine that size. And then all of this data is just reported for performance purposes. So let's look at another situation. Let's change this to 500 CFM. And I'm going to look at a couple different properties here because I'm trying to find a unique condition for you guys. Also with these inputs, if someone enters a design neck velocity that's not available, the message center will flag that. So design neck velocity is not found, revise that, or change the override neck size. So you get that happening. Let's go to 800. So if you were unsure of what values were available, you can just go and look here. So we have 400, 500, 600, 700. So all of these values are in the performance table. And that was a very complicated formula to get that to error check that. But let's see what we got now. Perfect. Okay, so I entered 500 CFM. We auto-sized to a 12-inch neck. And our design neck velocity is 800 feet per minute. So if we look at the data category, so max neck velocity is that design, and that's 800. However, I'm looking up 700. So why are we doing that? Let's go take a look. All right, so the way the auto-sizing works is first you're using the design neck velocity. So 800 feet per minute, we're going to go and find 500 CFM under the 24 by 24. So this 12-inch neck satisfies that 800 feet per minute and also the CFM. So instead of reporting this data, because this is actually a bit oversized now from what we actually want. Now, and the user manual talks about this, now we shift to the left and we start checking values this way. So sure enough, this value meets the 500 CFM. This one does not. So I'm rounding up in all the cases. So essentially now the performance data is coming from this as being a better representation than this when we're scheduling 500 CFM. We've talked about interpolating between these values to get even more precise data. That makes things even more complicated than what they already are. So for the moment, we're conservatively rounding up for noise criteria and whatnot. So the throws, however, we're rounding up as well. So if you wanted to get a certain distance, just be aware of that. Just look at these tables as you're looking at the values, just so you're informed of what the family's doing. And then let's just validate one more point since we're here. Okay. So a 12-inch neck, So 500 CFM is covered by this one. So we have 5, 8, and 16 for throat and 21 for NC. Sweet. Just validated another point. You know, I haven't talked about this yet, but one of the really cool things now with having performance tables at air terminals is now we have dynamic pressure calcs available for using in the duct system. So this really just opens up doors to so much more to come with these performance tables. So once again, thank Zach and Drew. Thanks.